Hello students, we will continue with our presentation on high-tech architecture and we will look at some more points concerning high-tech architecture in this part 3. We will begin with another example of a building that was a precursor to high-tech architecture, and that was the Eames House by Charles and Ray Eames in 1949, just after the Second World War. Now, why was it a precursor to high-tech architecture? Because it also used off-the-shelf steel frame members, industrial windows and cladding panels which could be bought in a factory, brought on site and assembled, something which was very close to the idea of the high-tech building. The architecture in which there is a logic of product design and industrial assembly. The steel frame has been visibly expressed and not hidden. This also anticipates the high-tech principle of revealing the skeleton of the building. The structural grid is dictated the layout and the appearance of the building, just as it was true for high-tech buildings, where the structural grid would guide architects like Norman Foster, Richard Rogers and Michael Hopkins to put together their buildings. The buildings appear to be assembled on site from a kit of parts, which also foreshadows the high-tech's modular and demountable systems, buildings that can be also put together in a kit of parts, just as Richard Rogers had said. I have talked about it earlier, and it's lightweight, it's a transparent design, it's an honest expression of materials, again anticipating the high-tech architect's pursuit of lightweight structures, clarity and minimal use of material. But the demerit was that Eames House had poor visual quality overall in its mass produced components. It was not up to the standards that high-tech architects were wanting, which we would see later, very exacting standards. Thus, the glazing mullions or the aluminium flashing, the steel truss, in high-tech architecture all of it should look right. So when high-tech architecture actually began, there was a need to solve this aesthetic problem of quality of the materials, and therefore these architects, they started collaborating with product manufacturers, and these product manufacturers agreed for the modifications that high-tech architects wanted in their buildings. Specifically, for example, in the three key ones, Lloyd's of London, Centre Pompidou, HSBC Hong Kong, there is a system through which, once the products have been modified or designed as per their specifications, these pieces, the system of various components passes into this select group of products approved by the high-tech architect. For example, as you see in this slide, though it is not a high-tech building, but it is showing the idea of it, that there is a sandwich panel in the floor slab, and that was used in HSBC. Then again, for bigger projects like the HSBC, the collaboration was done between the architect and product designer, and very specifically Norman Foster initiated what was called as design development, a team where multiple specialist manufacturers were to co-design these elements specifically for HSBC. And a percentage of design development was then kept, a certain amount of money, like a car manufacturer would invest a certain amount of money for developing a new model. Similarly, the investment was done for this kind of design development of various components and parts of the building, which will be brought on site and assembled, factory produced modularly, brought on site and assembled. But the difference here is that in this case, the car manufacturer, the industrial person is not going to pay, the client actually pays. It goes from into the part of fees that the client was supposed to pay. As a result of this, this process of design development is generally very rare even today. This was something which is very specific to some of these high-tech buildings that came up. Some more examples of custom developed HSBC elements are the steel mega columns and trusses, which were designed for ease of shipping and to be bolted on site. They were fabricated in the UK. Then there were the service modules that were pre-integrated units for AC, electrical and plumbing that was plugged in on site, brought from the factory and plugged in on site. Others were facade units like curtain wall panels, which were fabricated in Japan to exact tolerances with shading devices and maintenance access points, and they were brought on site and assembled. mirror system, very specifically one device called the mirror that you see here within the building, and it has one more part on the outside that I will show you. This rooftop sun scoop mirrors were also designed and then they were brought on site and executed. Now this mirror is supposed to bring daylight into the atrium of the HSBC building. We have already talked about the toilet pods in the plug-in pod section of our presentation last time, where these fully built factory manufactured pods were shipped from Japan and installed on site. Thus the HSBC headquarters, the HSBC building became less a place of fabrication and more it became an assembly plant where materials were sourced globally. They were precision engineered components based on the aspect of design development that Foster had initiated. They are brought on site, bolted together into this iconic high-tech building. That is why this building at that time proved to be the costliest tall building in the world, having a cost of around $640 a square feet. That was exorbitant for a tall building at that time. So for Foster, quality and sophistication of building technology was important for high-tech design, but according to Jane Kaplicki, there is a point of controversy. This Czech-born architect said this is not enough. He was known for his futuristic, organic and high-tech inspired designs, and his famous works are these Selfridges in Birmingham in 2003, which is a very fluid biomorphic facade with 15,000 aluminium discs on it. Then there is the Lord's Media Center, you might have seen in several cricket matches, which he finished in 1999, which is a spaceship like form. Now what did Kaplicki say? What was the point of difference in the view of Kaplicki? He was looking at a futuristic vision for building design, which he said is actually high-tech design. He said merely using glass material and neoprene and other materials is not high technology. High tech is especially the use of aerospace technology in solving building problems. Why specifically aerospace technology? Because there is extreme precision, lightweight materials and advanced fabrication methods. High-tech architecture should not just look technical, but adopt some rigor and innovation that is being used in the aerospace industry. With this definition, we realize that much of high-tech architecture, and I will come to that point later again, is actually about style and not true high technology. I will refer to that point again. Coming back to what Kaplicki said, using aerospace technology, aluminium alloys, composites and prefabricated modules not only reduce weight and maximize strength, he used this aerospace technology in the Lord's Media Center, which became a classic example of true high-tech architecture. So the difference is between true high-tech architecture versus a cosmetic high-tech architecture. He criticized architecture just by having these pipes and ducts and steel kept on the outside as aesthetic display that is not truly high-tech according to what Jan Kaplicki said. He saw aerospace as high standard of technological design and wanted architecture to match it in its innovation, precision, material intelligence, not just style. In fact, the Lloyd's Media Center used the very technology that is used for making aeroplane shells in forming the entire shell of the Lloyd's Media Center. So he actually put his money where his mouth was, and he actually did that to make the Lloyd's Media Center into a truly high technology building. So if you come back, if you try to look at it that way, you might have heard or seen any picture of the Concorde, which was the first supersonic passenger aircraft to be built. It was in service flying between Europe and United States. It has been discontinued for several reasons, but its overall form was entirely determined by technological performance. Its stylistic considerations or aesthetical part was only confined to the logo design or the treatment of the soft furnishings inside the aircraft, but the real high tech, when performance requirements were allowed to determine form without compromising for a purely visual effect. That means you are not going to design the aircraft or make certain changes or compromises to have a better aesthetic or a better form. The form is a direct result of the technology required to make this aircraft fly at supersonic speed. One example that is quoted is that of the Crystal Palace as a true high-tech building, because this building that came up in the 1850s around that time was not really so much about form as it was about putting this entire exhibition together under one single roof, and it was completely composed of steel, iron, glass at that time when it was not normally being used, and it was completely assembled modularly and put together where form was not the most important. Now that can be contradictory because it does have a certain form, there is a certain symmetry about it, but that was, I would say, a much lower point in this case. It was a very much solving a technical problem. But when we come to today, the high-tech buildings of the late 20th century that we talk about, in many of them it's actually about glorifying technology. So keeping aside that little controversy, let us come back again to our high-tech discussion. And in high-tech architecture, structures and services are celebrated by placing them visibly in the exterior. Engineering becomes the architecture, the pipes, ducts, escalators and trusses etc. are not hidden but showcased. Technology is not just functional, it is aesthetic and symbolic of progress, and it creates a building that looks like a machine. It could be for living, for working, for culture. As Corbusier said, a house is a machine for living. Exposed structures and services are visible distinguishing features of these buildings, but not all buildings expose services. We have to be clear about that. If we compare these two buildings by Richard Rogers, Lloyds of London, and again HSBC by Norman Foster, again we will keep on referring back to these three key projects which form the fundamental foundation of high-tech architecture: St. Pompidou, Lloyds of London, HSBC, but we will go on to refer to other buildings. As I have told you before in my presentations, another thing that I am trying to do is to introduce you to a large number of buildings and architects so that you get a very good idea of contemporary or modern architecture. Now in these two buildings, in case of Lloyds by Rogers, it is packed visibly, having a complex arrangement on the outside. But the same is not true for HSBC, where there is a smooth, elegant skin and the services are not exposed but they are hidden beneath the skin. Another way of glorifying technology is when we come to structures with tension members in them, which are visible tension members. Expressive power of steel structures, in this case converting the industrial shed into expressive architecture with these metal skins, bright colors, bold graphics and very decorative tensile structures. No doubt these tensile structures are genuinely holding up the structural system or holding up the structure of the building, as in the case of Renault Distribution Centre by Norman Foster and the Schlumberger Laboratories by Michael Hopkins, but it is also for aesthetic purposes, as I have talked, engineering for aesthetics. So when we, even as simple as external cross bracing, which was seen earlier in the Reliance Controls factory by Foster and Rogers in 1967, later on in 2001 in the 88 Wood Street building, in the Centre Pompidou and in the Inmos factory by Richard Rogers. Now this was an engineering necessity that was celebrated on the facade, and actually it is very transparent and legible to show how the building structure is actually working, and it had most influence of high-tech architecture, or rather high-tech architecture was most connected with airports, offices and cultural spaces. Later on this same bracing evolved into the die-grid system in buildings like the Hearst Tower and Swiss Re, which I will show you in the upcoming slide presentations. Now the first trusses above roof we find in the Patera buildings and elaborated into series of variations of mast and suspension rod theme, but like we find for example in the Renault Distribution Centre. It's mast supported and rod suspended roofs four major British architects, Richard Rogers, Norman Foster, Michael Hopkins, Nicholas Grimshaw, explored the potential of such structures. So high-tech architecture in these kind of structures evolved from simple exposed trusses that we find in the Petira building to mast and suspension rod innovations that we find, for example, in the Eames factory, to a more dramatic tensile mega structure that we find in 1991 in the Stansted Airport by Norman Foster. So in this building, for example, in going back to the Eames factory, the outer steel structure is supporting a roof beam via tension rods like this. These tension rods are supporting these beams. There are these masts from the mast, tension rods go out, hold up the beams, and thus the entire structural system of the factory, and the mechanical plant runs over the central circulation spine of the factory. So here it is, how even in the PA Technology Center in Princeton by Richard Rogers, the entire services are running over the central spine. Its structural system is very much similar to the Eames factory, but there are disadvantages of exposing steel structures, and that is that exposed to weather there are frequent maintenance problems. So we have to paint the masts and the cables, and that is not easy or cheap, but it does bring some color and some aesthetic into the building. The suspended roof membrane is punctured at support points, and thus it creates weak points. But when we come to these factories, we realize how amazingly the structural system has been put together. There is axial symmetry in the PA Technology Center, for example. The relationship between plan, structure and services shows great elegance and symbolic power. In fact, if you look at this structural system with these masts and the central spine, then these tension rods holding this entire frame, and by holding this frame, it is completely making this space column free. The entire space becomes column free, and thus a relatively small building actually has a big architectural appearance, and the contribution of structure engineer becomes very important. Therefore, such kind of columns, standard RCC columns, are completely rejected in high-tech architecture. At least in these buildings, we would not then list Lloyd's of London in that, because it did have precast RCC columns and cast in situ columns. Hollow steel columns, water filled, in the Pompidou Center, where this is meant for passive fire protection. It keeps the columns cool under fire stress, because the columns are exposed, and this becomes a fire resistance strategy for Pompidou. So there is high-tech aesthetic, technical innovation is integrated with a bold aesthetic expression of the building by using water-cooled columns. When it comes to the trusses that are there exposed, they are dry insulated for fire protection while expressing the steel as a part of the architecture or the aesthetic. It is essential for structures and services to be on display. That is a principle behind high-tech design, so these members have to be fireproof. So dry insulation for trusses. Then we come to the joints. There is spray-on fireproofing on joints. Dry insulation for trusses is not possible for joints because there are a lot of curves and recesses between them. Thus, there is a thin spray of fireproof coating given to the joints to cover all the corners and curves, and thus the joints start giving a clean visual expression. So, because the mast, the trusses and the joints are exposed, these methods of fireproofing have been applied on them while continuing to maintain this kind of aesthetic expression of the building. Again, in Lloyd's of London, the fire safety method is fairly conventional because the columns are either cast in situ or precast concrete structures. In HSBC, the floors are not supported on columns, but they are hung from these coat hangers. As we know, as we mentioned earlier, that just like Pompidou, just like even Lloyd's, HSBC also has an exoskeleton. And these hangers that you see here, they then transfer the load to these 8 masts in the building, and the advantage of that is that you get a column free plaza at the ground level. These steel mega columns and structural members, that is the steel masts and the coat hangers, these steel members are spray applied with ceramic fiber fireproofing, followed by cladding them with aluminium. So the entire building structure has a very high-tech metallic finish, and it is also protecting the fireproofing from the weather elements. So just to recapitulate, we have seen function and representation, we have seen the mass production problem, we have seen the plug-in pod, we have also gone through just now structures and services glorifying technology. Let us come to the last part in this section today, and that is space and flexibility, something called Omniplatz. What is Omniplatz? Now, in space and flexibility, we know that these buildings have a complex exterior but a simple interior. Buildings to adapt to new uses over time without major rebuilding is the thought behind it. Therefore, interiors are kept open and column free. The services are placed outside so that they can be upgraded or replaced, and interiors can adapt to different internal layouts. For example, in Central Pompidou, the same interior can be an art exhibition, a performance space, a conference center without major alterations. The building elements, steel structure, exposed pipes, air ducts are clearly expressive of their technical function, but the form of the complete building from the outside does not clearly show us what is the intended use of the building. The form is very complex. Pompidou, Lloyd's particularly, it is not clear what the intended use of the building is. The molding of the space to suit a particular function or to have a visual effect is not something the high-tech architects focus on. Their space is defined by technology, engineering and services, and turning the building into a visible machine. Therefore, because the building is such a complex organism on the outside, inside it can be completely free and simple. Like in Lloyd's of London, it is modular in plan, which each floor can be altered with addition and removal of partitions and walls. So, complex exterior but very simple interior. The site is irregular, it does not blend with the surrounding, this particular site of the Lloyd's of London, and the attempts were made, and I have talked about it earlier, how towards the 12-story side it matched the buildings on the side, the 6-story side it matched the urbanscape on that side. So the building is stepped down in the main volume to have this kind of correlationship with the urbanscape, but is still totally not able to adapt to the context, and that is always characteristic of a high-tech building. This is the Lloyd's of London as we see it from an aerial shot. These are the 6 towers that are on the side of the building. This is the central space, which is very neat and tidy. Now, instead of an enclosure that is just a room or a hall, this interior space is called Omniplatz, a flexible, fully serviced open space, open plan space, a service zone. That means it is completely surrounded with the services it requires. The whole concept of servant and served spaces we've talked about earlier came from Kahn, who gave this strong formal distinction between the two. The servant spaces are spaces that serve other spaces. For example, stairwells, corridors, restrooms are all servant spaces, and any other back of house function like storage, etc. So we see that in the Richards Medical Lab in the University of Pennsylvania in 1965. So when we see servant and served spaces, the difference is that there it does not say that the entire space will be fully serviced. In Omniplatz, it is specifically a fully serviced universal space or universal platform. The open plan is a served space, no doubt, but it is physical flexibility only in the case of Louis Kahn. In the case of the high-tech buildings, the Omniplatz, rather than just remaining a served space, becomes a serviced space. That means the open space is fully equipped with services all around it, and the space is immediately usable, and also usable in multiple ways. Now coming to the idea of the universal space of Mies van der Rohe. The idea was to have this space which was open, adaptable and free from programmatic constraints. Now here the other aspect comes in of adaptability. Louis Kahn talked about the space being served So we go on to the service space. Mies talked about the space being universal, adaptable and having free from all programmatic constraints. So the structural steel frame, the utilities core are all pushed to the edges and the space becomes uninterrupted. When we look at say the Farnsworth House, the services are not pushed to the extremity, they are pushed right in the center, thus so that we can have free uninterrupted glass view all around it. The occupant in the Farnsworth House defines the function and use of the entire space over time. In the Crown Hall, all the services are on the periphery, the space is a universal space. Thus, the space of Mies van der Rohe is closer in that sense to the high-tech space. So we see that in the Farnsworth House, in the New National Gallery, the Bacardi building, the Crown Hall Mies follows the same concept. Thus, high-tech architecture merges these two legacies, from Mies the open, universal, flexible interior, and from Kahn the servant and served space. All servant elements are pushed to the exterior and a completely open, universal, serviceable, usable interior Omniplatz is created. What is thus the combined evolution? Universal space of Mies plus the servant and served idea of Kahn leads to the Omniplatz, a high-tech serviced space on the inside. We find that even in the Leadenhall building, this is the served, the fully serviced zone, the Omniplatz, and the services are on the periphery of the building. The Omniplatz in the HSBC Hong Kong. Thus, logical approach to maintain the functional essence of a bank is what Omniplatz leads to. For example, in HSBC, this large interior open space which is easy access to all the floors improves the functioning of a bank. The Omniplatz we see even in Centre Pompidou, where all the services are on the outside of the building, and then this is a fully serviced Omniplatz. So Pompidou becomes a multifunctional building with art galleries, museum, library, theatre, concert hall, restaurant, all within the one building but having a basic same interior element, this massive blue truss that you see. Whatever the function of the Centre Pompidou, the same basic interior element continues on all of them. The whole design is thus committed to the idea of flexibility. Thus, this one space can have flexible or multiple uses, as you see here in this picture, in this slide. Now the modern office blocks, when it comes to flexibility, it can have flexibility in partitions. But high-tech flexibility went a stage or a step further with demountable even external walls, roofs and structural frames, flexibility in external walls. Elevation is like plan, it's an abstract grid which it can accommodate different functions, can have an insulated panel, a door, open window, a metal louver. It can be replaced, it can new kind of panel can be added to the external facade of the building. Wall configuration can respond according to the change in the internal space function. Theoretically, it can be changed easily since the assembly is of tough and dry components, but in practice such alteration is very rarely done. The importance is that this abstract concept is there. In fact, there are many concepts with high-tech buildings that are there in abstraction, like the plug-in pod for example. Though they can be dismantled and reconfigured and the maintenance can be done somewhere else, but it is not being done. In the Lloyds of London or even in the other plug-in pod buildings, it has not really been done. Now, when we come to the terrace for example of the Centre Pompidou, there is flexibility, very simple flexibility what I am talking about right now, that the elevation itself is like alterable like the plan. Here if you see this terrace, you find the same truss, and this entire terrace can be enclosed. It can be enclosed and it can then work as an enclosure. Thus the building is like an adaptable container which can evolve with time. In Lloyds, the rectangle is eroded on one side to match the scale with the surrounding buildings to relate to the urban context, but here also there is a possibility of lifting these floors and to bring them the lower floors to the height of the taller part of the building. So all three buildings are open-ended and seem incomplete, so that extension is possible without damage. In fact, these cranes provided at the top of these buildings actually symbolically show that the buildings are incomplete. Now, difficult to define the typology of buildings flexible to adapt to any function. Practically, this is associated to a narrow range of building types, typically the old industrial shed, which used to be brick clad with a sawtooth roof and with a chimney, but it has been replaced by this example like the Renault Center, which is shiny metal clad shed painted with bright colors and decorated with bold graphics. So we have buildings which actually are the progenitor or the precursor to the high-tech industry building, like the Fergus Schuler's factory and the GM Tech Center, one by Walter Gropius, the GM Tech Center by Eero Saarinen. High-tech industrial architecture like this building by Herman Miller, the distribution center, the Herman Miller Distribution Center by Nicholas Grimshaw in 1976, or the Financial Times print works again by Nicholas Grimshaw in 1988, both examples of high-tech industrial architecture. Thus the simple high-tech shed, another one which was the Reliance Distribution Center again by Nicholas Grimshaw, it was done in India. This factory shed has a long span structure with a simple skin enclosing a completely universal space adapted to have different functions. It could be a supermarket, leisure center, art gallery, but all of them have the basic form of a factory. Thus, the industrial shed typology can be applied to high-tech buildings like supermarkets, indoor swimming pools and sports centers, like it is adopted in the Sainsbury Visual Arts Center, which also has an industrial shed typology. The Sainsbury Center is just like an industrial shed. Or it could be there in an exhibition hall like the Barton Exhibition Hall. I have already mentioned these buildings earlier, but I am putting them together here to show you the building typology that matches with the high-tech architecture. Thus, or we have the industrial shed typology in the PA Technology Lab again by Richard Rogers. Office also can have industrial shed typology. This is the Orange Operational Centre and Customer Service Facilities in the UK, again by Nicholas Grimshaw in 1998. Or a brewery can have this high-tech industrial shed typology, where the factory initially was taken from a house and this entire high-tech brewery was constructed. But one thing is that in housing, the influence of high-tech architecture is at its weakest. Though there is a progenitor, a precursor like the Farnsworth House, but examples of houses are very few. For example, the Hopkins House by Michael Hopkins is based on the industrial shed typology and it is a part of high-tech architecture. Similarly, Richard Rogers House in UK in 1968 is also built on the concept of a high-tech building, very close if you look at it to what was done by Charles and Ray Eames, very similar to that concept. Or the Bentham House in Netherlands by Bentham Crowell Architects in 1984. The Park Road Apartments by Nicholas Grimshaw in 1968. The high-tech building typology is biased towards certain building types, or rather we should say certain client types. Industrial technology clients commonly are from the industrial or the business corporations. The very concept of high-tech architecture leans towards industrial and business type of buildings rather than dwellings and houses. We will stop here and we will then start with the aesthetics that govern high-tech architecture. There are 6 basic rules. We will come to that in the next presentation. Thank you.